Hello guys, today I am presenting you with group number 11, Firefly's team and its autonomous trash collection system. With our project, we decided to try and come up with a solution for the ever-increasing cost of sanitization and unsafe work environments in our cities. Our slideshow is broken down into sections with the introduction encompassing the problems our customers are facing, our solution, how the robots work, their design, and how they collaborate with each other.
Hi, my name is Jordan and I designed the Little Dumpy robot.
Hello, my name is Daphne Lama, and I designed the sorter robot, which you will be able to see later in the presentation.
I designed the robot, the Carter, that you'll see later on.
Also, our conclusion for this video and any references that we use will be found at the end of the slideshow.
So here's the problem at play. There's no such thing as a way. When we throw anything away, it must go somewhere. Cities and local governments are left to be solely responsible with the undertaking of waste collection and landfill disposal sites, yet communities still suffer from trash buildup and pedestrian litter. Whether further automation could be a more complete solution to the street litter and the burden of recycling discarded goods, our system plans to solve that issue. As mentioned by Jonathan, our customers are government sanitation and recycling facilities, corporations trying to go green, and community and school-based programs focusing on sanitation outreach. One of the three major problems facing our customers is that the hazards of sanitation work are not well understood or documented, but we know it can lead to a host of long-term health problems or even death. There's also a lack of community and corporate interest in going beyond greener products. They don't change the negligent disposal of goods or make communities more aware of waste production. Furthermore, conditions to collect waste can also be dangerous. We have three ways we plan to solve this problem. First is autonomous collection. We plan to have stage bots with different functions to have a 24-hour fleet of trash identification and collection for communities. We also plan to assist existing systems. Sanitation systems like garbage trucks or sorters primarily work off routes or fixed locations, but we have the time to go in between those locations. We also plan to reduce waste overall by having autonomous collection systems that can decipher between material and save scraps for recycling.
Our team designed our robots to be fully autonomous and work with current infrastructure for faster implementation of our system, meaning that they can navigate their environment safely and efficiently through a camera-based system to be able to watch their surroundings and make data-driven decisions. Our robots are the Scumba, presented by me, Jonathan, the Carter, presented by Briley, Little Dumpy, presented by Jordan, and the Sorter, presented by Daphne.
Fortunately, Jonathan wasn't able to record his robot presentation, but I will be able to represent it for him instead. Scumba is a small-sized, low-cost robot commissioned to operate exclusively on paved surfaces like city streets and highways. This is because of its integrated vacuuming system designed to pick up any debris smaller than 8 inches in size, proving this most effective over any paved surface. Its small size allows it to navigate through spaces where the other robots are not able to. This flowchart describes Scumba's algorithm. When first turned on, the robot will conduct a series of checks to make sure the robot's systems are working properly, load this database, and begins analyzing its environment for debris while it moves around vacuuming the area in which it was deployed. Scumba's battery pack allows it to cover an area of at least 5,000 square feet before it needs to recharge.
This trash collection robot. This mid-sized robot has 4 mechanical arms to pick up waste objects like cans, bottles, and small boxes. It is fit with 4 all-terrain wheels for urban and green space navigation. The Carter is powered on, and then a series of decisions are made based on what information the sensors gather in the environment. Trash is collected until designated sector is clean or chassis is full, and then returns to home base for final. Here we can see the circuit with the DC motors for mobility, servo motors for arm mechanics, and our motion and distance sensors as inputs for our outputs, which are the motors to then make a decision and respond appropriately.
My bot, the Little Dumpy, features sensors on the front and the side to help it collect trash in its area. My circuit flowchart shows a series of checks with the bot turning on, it detecting the distance that's in front of it, and if that item is trash or not. My circuit essentially solidifies these decisions with having wheels that correspond to the item that it identifies. There's also a remote to help relay information back to the user that is watching this bot.
Hello, my name is Daphne Lama, and I designed the sorter robot. In terms of its appearance and mobility, the sorter is a different take on the conventional pick-and-place robot. The sorter is designed in a spherical shape to help it retain its mobility, which can help it scale large trash piles that it needs to sort. The sorter is also designed with different sensors, such as force sensors, ultrasonic distance sensors, and optics to help it recognize and sort different types of waste.
And now some brief clips to show our robot collaboration system. Our robots operate based off of size and the type of material they need to collect.
We wanted to include some existing solutions, which if you've been to certain airports, you've probably seen these smart recycling bins that sort trash as it is thrown away. We are also seeing the powerful use of AI to recognize different trash materials and effectively speed up the sorting process. As we are all aware, man-powered trash collection and disposal services are the dominators in the waste management industry currently. As we progress, we are seeing more funds allocated to the reduction of waste, and that is encouraging to see. Despite the effectiveness of the solutions presented prior, our system differs in the enhanced mobility. Our robots do not have fixed processors and sorters and are able to easily adapt as necessary when things change, such as routes. Our robots can also be implemented in various ways. They can be sent into operation autonomously or can be used in conjunction with humans to do less pleasurable jobs. Our robots also provide enhanced safety for our trash collection workers. The bots will be able to collect and dispose of hazardous waste without risking human infection. Overall, as waste continues to increase and accumulate, employing robot fleets to aid in the issue would only benefit cities through the optimization of safety, efficiency, and can possibly even reduce labor costs for companies and organizations.